Now let us see some problems in second, that is Butterworth filter and Chebyshev filters. Now let us see some problems. Design a digital Butterworth filter satisfying the constraints. They are given the constraints and with t equal to 1, see using impulse invariant method. This is a repeated asked question. Here we know that alpha equal to, that is the passband attenuation equal to 0.707, and the passband frequency it is given as omega p equal to pi by 2, and the stop band attenuation it is denoted as alpha s equal to 0.2, and the stop band frequency omega s equal to 3 pi by 4. Here first step we are specifying the passband frequency and stop band attenuation in dB. Therefore we are going to find the value in alpha p and alpha s in dB. And next the second step we want to find the analog frequency. Since it is going to find by using the impulse invariant method, omega p equal to analog omega p divided by capital T. Similarly omega s equal to omega s by t into t. Therefore by using the formulas we are going to find the value for digital omega p and digital omega s. And the second step it is used to find the order of the filter, that is capital N. By using the formula that is shown in this screen, we are going to calculate the value for N. Here while we are calculating the values, the calci must be in radian mode and pi equal to pi itself. Now N equal to 3.924, therefore it is rounded to the next higher digit integer value. And next we are going to find the normalized transfer function. Here for n equal to 4, normalized transfer function h of s equal to 1 by, this is the normalized transfer function, s square plus 0.76537s plus 1 into s square plus 1.8477s plus 1. And the fifth step we are going to find the cutoff frequency omega c by using the formula omega p by 10 the power 0.1 into alpha p minus 1 the whole power 1 by 2. And therefore we are again finding the value, and at last we want to find the transfer function of h of s. Therefore h of s equal to h a of s at s equal to s by 1.57. Therefore substituting the value and calculating, we are getting the value for h of s. That's about the design by using the Butterworth filter, that is in the analog domain. Now they are asked to find by using the impulse invariant method. Therefore while we are performing this by using the impulse invariant method, we want to perform the partial fraction expansion, and we are applying the partial fraction expansion. We are splitting the formulas into the given values into 2 or more values, and here after finding the values, here we are finding the values, and after at last we are finding the values, we are adjusting the equation according to the formulas in the case of impulse invariant method. And finally we are applying the value for h of, that is we are finding the value for h of z. While we are finding the value for h of z, we are assuming that capital T equal to 1 second. So at last we are simplifying and finding the value for h of z, that is the digital transfer function, that is h of z. Now we can see one more problems in Chebyshev filter. Design a Chebyshev filter for the following specification using bilinear transformation. For 0.8, this is a given constraint. Here also the passband frequency attenuation is given alpha p, and the passband as frequency omega p is also given, and the stop band attenuation alpha s is given, and the stop band frequency omega s is also given. First step we want to calculate this in terms of dB. Therefore that we are calculating the passband attenuation and stop band attenuation in terms of dB. And the second step we want to find the analog frequency. Since here we are using the bilinear transformation, therefore the formula for bilinear transformation is omega p equal to 2 by 3 tan of omega p by 2. Therefore by using this formula we are going to calculate the analog its frequencies. And third step we want to find the order of the filter by using this formula. This is somewhat different while we are comparing to the Butterworth filter. Therefore n equal to 1.207, it is rounded to the next higher digit integer value. Now we want to find the poles for the Chebyshev filter. For that first we want to find the value for alpha k, then find the value for epsilon, then find mu, find a and find b. After that we are substituting the values in the poles, that is here since we are having k equal to 2, we are having n equal to 2, we are having 2 poles, that is k equal to 1 and 2. Therefore find s1 and s2. Now we are going to find the denominator of the transfer function, that is first s minus first pole into s minus second pole. Therefore while we are substituting and simplifying, we are getting the values like this. Now we want to find the numerator of the numerator of this transfer function. The numerator depends upon the value of n. If n is even, let us assume n is equal to 0 in the denominator polynomial, and the result is divided by root of 1 plus epsilon square. Therefore, that value is equal to the denominator. Therefore, h of s. Now, the denominator of the transfer function of the analog filter can be given by this equation in equation 7. Now they are asked to find by using the bilinear transformation. Therefore, while we want to perform this by using the bilinear transformation, we want to replace s by 2 by t, 1 minus z inverse divided by 1 plus z inverse. Therefore, we are just replacing and we are calculating. Finally, we are getting the value from h of z equal to 0.28 into 1 plus z inverse the whole square divided by the denominator. That's all. Thank you.